This time we've got a quadratic equation. So remember, when solving it, we're going to factorise. This one, well, where we can. This one is able to factorise nicely. Remember, don't divide by sine of x, because sine of x could equal 0, and if it's equal to 0, you can't divide by 0. So that's out. Always factorise. So we get this situation. So this part must be equal to 0, or this part must be equal to 0. So sine x is equal to 0. Where's x equal to 0? 0, pi, 2 pi. Sine of x is equal to 1 at pi on 2. So there's our solutions there. Our quadratic here works out. If you want to do a substitution and use that to get down to your answer, that's fine. This one, if I can recognise it's a perfect square, but again, the more experienced you are, the better, easier that is to do. If you need to substitute to get down the answers, not a problem. So it is a perfect square, cos x minus 1 all squared, which means that cos x would have to be equal to 1 for that part in there to be equal to 0. Cos of x is equal to 1 at 0 and 2 pi. Again, this has got a common factor. Factorise it out. So it leaves us root 3 tan x plus 1 is equals 0 in the bracket. So tan of x is equal to 0 at 0, pi and 2 pi. And root 3 tan x plus 1, manipulate it down to tan of x is minus 1 on root 3. And we get our solutions as we've normally done there, 5 pi and 6, 11 pi and 6. Again, manipulating this one down, similar to what we did before, we get the two equations and get our two solutions. If you want to solve it this way as well, that can be done, but it's not a problem to do it this way.